Technology represents the powerful tools that the learner can use to facilitate his or her own learning process. The pre-service teacher technology competencies identify areas of proficiency for teachers to effectively use technology resources to create the conditions that optimize learning. Teachers need knowledge of the basic technology equipment operations and concepts, technology resources and tools for information literacy, and technology resources and tools for content areas. More information on this can be found in the Technology as Facilitator of Quality Education model. In this lesson, the students are being introduced to Artemis, a database developed by the Digital Library Project at the University of Michigan. This database is a collection of websites that the students can use to research information on sound waves in preparation for a class discussion. The teacher demonstrates technology competency number 17 by creating a learning activity that teaches students to use a database to collect, organize, and analyze data.
And now we're going to look at another database. This is a database that it's a collection of websites that have been collected by the Digital Library Project at the University of Michigan. So it seems like you're going out on a search engine, but you're really not. You're searching on a controlled database. Let's try both ways that we talked about before. Let's enter our question that we have come up with. What was our question?
How does sound travel?
How does sound travel? Let's type that in the search box. One of the things I think we should do is let's go and do sound. Let's erase how does sound travel. I want to just quickly give you a comparison of the kind of websites that'll come up. So you didn't know exactly what you're going to do. You're going to go for the broad term, right? And this is also going to show, I love this. It gives you a lot of help. This website will allow you, look at animal communication, frequency, that's another word associated with sound, linguistics, vibration, waves. All of those search terms are going to help you. So you can search on Artemis with those search terms, or also you could jot them down and search on general search engines. Look how many more websites that we got when we just typed in sound. Okay? Okay. All right. That's it.
Great. Thanks.
That's how we use it. It's a helpful site.
The exact same.
There you are. Now you should be connected.
Look at the other words.
Thinking there was something wrong with your computer there.
Double figure out what
Okay, make sure you're taking notes down in your handbook, Kelsey. You're going to want this.
I don't know what that.
Oh, right.
No, this is an activity.
Yeah.
No, it's not. It's loading an interactive science activity.
You don't want to do it.
So how are we going to do longitudinal waves? Look for longitudinal. Why do we hear echoes?
There are some nice interactives there.
Stream in this simulation and see what happens.
Yes.
In about 1 minute, what you'll do is let me know what you found as I go around.
Okay, quick. This is a okay, let's go through this. These calls out of longitudinal waves. You know what that means here? I'm not losing.
Sound waves. Waves and vibrations. Okay.
From the Artemis database, the students can access a variety of websites they can use to answer their research questions. Students then search some of these sites to find the information they need. The teacher demonstrates technology competency number 8 by designing a lesson that helps students learn to efficiently access World Wide Web information sources.
This is great.
What is this for?
Okay, so,
What displacement and velocity is.
okay. All right, when you're going, you're going to go, what we've talked about is velocity, right? The speed of sound, okay? All right, so there's your speed of sound, but you can it'll show you. Okay, this is your longitudinal wave.
What is a longitudinal?
Okay, that's what you want to look up. A longitudinal wave is actually how the sound travels, okay, from one place to another, and the molecules that it affects. So you always think that sound just goes from one place to another, but this is what's happening in between from when sound starts to where it goes, is that these molecules have to move in this fashion in order for that to happen, okay?
Should we save this?
So we have to move those molecules out of the way, yes.
Transverse wave is a wave with the motion of the medium being perpendicular to the motion. Yeah. So it means like if
Did
the
you
medium's
search under
like
science?
air,
Or did you search under
if
biology
the
or
sound's
physical
moving
science?
this way,
Biology.
Go under physical
the
science.
molecules are moving up and
Okay.
down.
She has pink hair and I don't.
So wait. So wait, a longitudinal is a flat.
Isn't that great? Now, if you wanted to prove that, I mean, here's a
longitudinal is a
thought
flat
for
wave,
an experiment for you, if you're thinking of something like that. Now that, if that intrigues you, there are experiments that you can design to see.
After finding answers to their questions regarding how sound travels, the students use Sound Edit software. This program allows students to see how changing the frequency and amplitude of the sound affects the sound wave. The teacher demonstrates technology competency number 20 by designing a learning activity that incorporates instructional software appropriate for the needs of the learners.
We're going to go on here and we're going to do an experiment on Sound Edit. Okay? This is a tool. Sound Edit is a program, a tool, which will allow you to design some of your experiments and gather some data. It will show you, as we did the button lab, to determine if frequency, okay, and amplitude are related at all, and do they affect one another? Does amplitude affect the pitch? No. No. Okay, and we're going to see just how on a wave that we see on an oscilloscope, how you would read that in order to determine if the frequency was high or low, and if the amplitude was loud or soft. This here becomes a tool for you to be able to design an experiment where then you can have some real data that's collected, right? Not instead of, well, I set the meter at 50% and it sounded like it was 50%, but, I mean, was it? You know, this way, depending on what your printout is, and then you can print this in the back room on the printer, you actually have data that you've collected, the waves, to prove to us that indeed this material allowed sound to travel faster. This material didn't allow sound to travel as fast because you've got the actual data out here, okay?
Somebody took out the working parts of one of these and put it into it 400. And it works. No, yeah, 400. I write about it. Alright, what's your thing?
And then for this thing, it's 100.
That tone. Get away. Make the screen vibrate. Oh god, we gotta try it. Try 800.
What are you doing?
You just find the tone. That's what we have to do.
So you go back. You have to do all of that.
We'll have to find the tone. Yes, find the tone.
800.
You know where it was? It was in that folder. I don't know why it was in there, but it was.
Hey, do you have Sound Edit?
They're after me.
You might want to lower your sounds.
Yeah.
If you go down to the meters, lower those sounds so that we're not driving each other crazy.